Okay, video two, guys. The first one we went over just basic what exponential and log form was, switching from one to another and using some of that to solve. Okay, now we're going to go one step higher here, guys. Okay, we're going to go one step higher and we're going to do something like this. What if I give, oh, and then I went over something like this too. Let's f of x equals 2 to the power of x plus 1, all of that minus 4. All right, this is an exponential. Clearly, it's an exponential graph. I am just going to graph this really fast. We went over exponential graphing the week before, but just for the sake of it, I'm going to graph this really fast. Okay. I know that there's going to be an asymptote at y equals negative 4. Y equals negative 4, that means the graph is not going to touch that. Okay, it's not going to go below that. Now, how do I know it's y equals negative 4? Right here, y equals negative 4. Now, the reason I know that is if I made this negative 4, if I made the y negative 4, and I add 4 here, I get that, which is not going to happen, guys. 2 to the power of nothing is going to get us 0. That's just not going to happen. Okay, a number raised to nothing is going to give us 0. So we cannot solve this. This won't happen. Simple as that. Okay, because if I said 2 to the power of 1, that's 2. 2 to the power of 0 is equal to 1. You're never going to get 0. Okay, so this is an impossibility. That's why our asymptote is at y equals negative 4. Because if we make y negative 4, it doesn't work. Okay, so asymptote, I'm going to do a hard line right there to show you that that doesn't pass that. Now, an exponential function, if you guys remember what that looks like. Let me rewrite. Okay, an exponential function, exponential growth in this case, and we know it's growth because this number 2. It's not a fraction smaller than 1. If it was, it'd be a decay where it would start going down like that. This is a growth. It's going to go like this. It's going to shoot back up. I can start plugging in some points here and figuring out this exponential function. I am not going to do that for the sake of just making this really quick. I'm going to do the following. I'm just going to make a couple quick points. I'm just doing this in my head real quick, okay, guys? If I plug, sorry, I'm doing an easier number. If I plug in -1, I get -3. If I plug in 0, -2. Okay, if I plug in 1, get 0. Okay, so we get an idea of what that looks like. And if you remember exponential graph, and then skyrocket. And it gets really close to the asymptote, but never actually touches the asymptote. Great. All right. Now I want to come up with a couple things here. I want to come up with I want to do the inverse of f of x. Uh-oh, the inverse of f of x. What the? Well, let's see what happens here, the inverse of f of x. Actually, you know what? No, I take that back. Before I do that, I want to get the y-intercept and the x-intercept. Sorry, I lied. I want the y and the x-intercept. Y-intercept, make the x 0. Let's make the x 0. Ready? Well, we already know what the y-intercept is. We could see it right here. The y-intercept is -2. Let's just make sure it's correct. All right, let's make the x 0. That would be 2 to the power of 0 plus 1 is 1. 2 to the power of 1 is just 2. 2 minus 4 is -2. We got it. The y-intercept is -2. We already knew that. Okay, next, x-intercept. A little more involved, okay? So turn your blinkers on right now because x-intercept is a little more involved. All right, the x-intercept, we have to make the y 0. So let's make the y 0. Let's see what happens, guys. We're going to make the y 0. So in order to solve this, I have to first move that -4 by doing +4. +4, +4. That gives us 4 equals 2 to the power of x plus 1. Now, Here's where it gets interesting. Do you guys remember? In the last video, I did something like this. If I have b to the power of, I don't know, b to the power of something is equal to b to the power of, I think the number we used was 8 in the last video. B to the power of what is equal to b to the power of 8? It's right. I'm telling you what it is. B to the power of 8 is equal to b to the power of 8. It has to be an 8. So essentially, if you have two of the same bases, b and b, you could just cancel those bases out. So the question mark is directly equal to that. So question mark equals 8. So another way to show that real quick. If I have, I don't know, let's come up with a letter. T to the power of x equals t to the power of 5. And I say, well, what's x? Simple. Same base, cancel them out. X equals 5, done. Let's try this one. T to the power of 3x equals t to the power of 12. And I say solve that. Simple. Both have a base of t. Cancel out the t. 3x equals 12. Divide by 3, x equals 4. Simple. Okay. So why am I telling you that? Well, if the bases are the same, you can just make the exponents equal to each other. Look at these two. Bases are not quite the same. That's a 2. That's a 4. But they're very closely related. They're like cousins, okay? They're very closely related. I don't know if that's closely related. They're like brothers or sisters, okay? Maybe like that. They're very closely related. Now take a look at this. 4 can be written as 2 to the power of something, can it? Because this right here is 2 to the power of x plus 1. 4 can be written as 2 to the power of something. 4 is the same as 2 to the power of 2. It is. And I'm just going to rewrite that 2 to the power of x plus 1. Now, why did I do that? Because guess what? Look at the bases. 2 and 2. Cancel them out. 2 and 2, cancel them out. Technically, if you want to cancel that, you can do log base 2 on each side, but we're not getting that right now. Cancel them out. That leaves us with, I just set the exponents equal to each other. Look, boom. So that's 2 equals x plus 1. Minus 1, minus 1. X equals 1. Now, what was all this work for? All this work was to find our x-intercept. Our x-intercept is at 1, 0. Yes, sir, it is. We already knew that. X-intercept is at 1, 0. We already knew that, okay? So that's how we're kind of using exponents to solve here, okay? Now, technically, we can use logs to solve that too, okay? We're not gonna, just because we don't need this one. Now, moving on to the next thing I want to show you guys based off this. So what I want to show you was, got all that, that's great. What if I asked you for this? What if, let's use the same function. What if I said, find the inverse of f? Okay, so remember this, how we find the inverse. I'm gonna make f of x my x. I'm gonna switch the y and the x. Switch the y and the x. Then we are going to solve for y. Simple as that. Okay, so I need to keep y here. Everything else got to move. First things first, add 4. So I have x plus 4 equals 2 to the power of y plus 1. Here's what's up now, guys. Excuse me. I want to keep that y. Everything else got to go. Can't move a plus 1 just yet because I got 2 to the power of y plus 1. I got to move that 2 first. If you want to move that base of 2, okay, as the power is an exponent to the power of y plus 1. Think about it. This is an exponential form. To get rid of it, I want to do logarithmic form. So here's the way to do it. I'm going to do it in different colors so you guys can see it a little bit better. To get rid of that base of 2, I'm going to do a log base 2 to that 2. Log base 2 of 2, hate the word 2, but it cancels out, okay? Log base 2. What I do to one side, I do to the other. So I'm going to have to do log base 2 of that, of x plus 4. So what I do to one side, I do to the other. I do log base 2 of 2, it cancels it out. So let's see what I'm left with. I'm going to rewrite this. I'm left with log base 2 of x plus 4 is all equal to, now remember, log base 2 and 2 cancel it out. We're just left with y plus 1. Do we have y isolated by itself? Almost. Not quite. The only thing left is that stupid plus 1. We're going to do minus 1 here. And that is our inverse. We just found it. It is base of x plus 4 minus 1. Log base 2 of x plus 4 minus 1. Whew! It's pretty heavy. Seems like a lot. Now, here's what I want to get to next. Okay? We are going to actually go and graph that. Okay? I'm going to take that and actually graph it. We're going to be graphing log function. Wait for the third video. Okay? So this is the end of the second video. We did x and y intercept of an exponential. We also did the inverse of an exponential. And we end up getting a log. So when you inverse an exponential, you get a log. When you inverse a log, you get an exponential, and so on and so forth. So let's create video 3.